Yes, Sasikan students, let's have another lecture on connected motion in laws of motion class 11 physics. So you see this is a pulley. Now two masses are attached to the pulley. One mass is m1, the weight of this is m1g. When it moves down with acceleration a downwards, the mass m2 is gets accelerated upwards, right? T is a tension, the pulley is moving in clockwise direction. Now, students, let's assume that M1 is greater than M2. Now you see the heavy M1, this will move downwards, then the lighter body M2 will move upwards, right? Now let A be the common acceleration of the system of two bodies. Obviously their acceleration will be same. Now the pulley we assume is light and we assume it is frictionless. When we assume it is frictionless, so whatever energy we are applying, the same energy has complete effect and no energy is lost. So tension in the string will be same on both the sides and tension will be upwards. Now on the heavier body, on the heavier body, the forces are acting. Okay, which forces? Number one, its weight, m1g. This is the heavier body. Its weight is acting downwards. Am I right? Weight is acting downward. Just wait a minute. Yes, students. The weight is acting downwards. Then number two, the tension T is upwards. Right? So as the body moves downwards with acceleration A, the net downward force on it is m1a. When it is moving downwards with acceleration a, so net force will be mass into acceleration will be m1a. This will be the net downward force. Net downward force. Downward force. Right? So obviously then we can say net downward force m1a is equal to what? m1g is the weight which is acting downwards and tension T is acting upwards. So M1A is equal to mg minus T. Yeah, you can also say that, all right. Now on a lighter body, we talk about lighter body. Now see that students, lighter body, what are the forces acting? Lighter body is M2. I'm talking about this body, lighter body. Weight always is acting downwards. What is the weight of lighter body? M2g, that is acting downwards, right? Number two, the tension is always acting upwards. Tension T is acting upwards. You can say this part of this side of the pulley is holding the mass. So it's applying the mass is acting downwards. The tension or the pull by the pulley to hold this is acting upwards, right? As if someone is pulling it upwards. Okay. So now as the body moves upward with acceleration A, this M2 will ultimately move upwards. It's moving upwards with acceleration A. So net force, net upward force, net upward force acting on it would be M2A. And M2A is equal to, you see, M2A is a net force acting upwards. Am I right? And also students, this net force acting upwards would be equal to tension T minus M2G, because M2G is acting downwards. Am I right? Very good. So this is the, you can say we are getting the second equation. This is the first equation. This is the second equation we got. All right. So when we add both the equations, we get m1g minus m2g is equal to m1 plus m2 into a, right? We can also say, we can take g common, m1 minus m2 into g is equal to m1 plus m2 into a. So from this, students, we will get the value for the acceleration with which this body is going downwards and this body is going upwards, right? Here is the pulley. So acceleration A would be equal to what? m1 minus m2 into g divided by m1 plus m2. It's very, very important formula, students, to be used for connected bodies. Okay. So now, students, you see that obviously acceleration is less than acceleration due to gravity. What is the value for acceleration due to gravity? 9.81 meter per second square, right? So we can see acceleration of a system of two connected bodies is always less than acceleration due to gravity, right? So now, students, if we divide equation 1 by equation 2, what we get? m1g minus t divided by t minus m2g. See, students, whenever you divide an equation, divide left side by left side, right side by right side, is equal to m1a divided by m2a. That is equal to m1 by m2. The acceleration cancels out. So from this, I can understand, students, m1 m2g minus t m2 is equal to m1t minus m1 m2g. Is it right? So see that what I get, 2 m1 m2g is equal to t into m1 plus m2. See that this term can come on the right side, minus becomes plus. So from this we will get another formula, T, that is tension. Tension is equal to 2 m1 m2 this into g divided by m1 plus m2. So the tension in the string is what? 2 times the product of masses times acceleration due to gravity divided by total mass. You always remember this, will be able to solve questions based upon these two formulas. So let's say, students, we are having a question, two masses are there, 10 kg. So this is our m1, and a bigger mass. Then other mass is 6 kg. So Jasmine, what is this mass? Hello Jasmine. M1 is 10 kg. So 6 kg is, yes Ishma, this is lighter one, M2, right? So this is our pulley. This is our pulley. So see that this is our M1, M1 going down, and then as a result M2. The lighter mass obviously will go up. You see, even if you have a takdi, even if you have, you know, what they call with which they weigh your vegetables and all, so they will put the mass here. Let's say they put 2 kg mass here, you know, and the vegetables they put on this side is only 1 kg. Obviously this will go down, right? So this will be equal when you put another 1 kg of vegetable. The same concept here, na? Heavier mass will go down, lighter mass will be accelerated upwards, heavier mass would be accelerated downwards, but the tension in them is same, right? That's interesting thing. Okay. Okay, so this is M1, this is M2, guys. All right, now he says at two ends of an inextensible string, pass over a smooth frictionless pulley. All right. Calculate acceleration of the system and tension in the strings. Very simple. Yes. Ishma, tell me the formula for acceleration. We have just derived.
So I joined just now. I don't know.
Don't worry. So, other girls, tell me the formula for acceleration. We have just derived. So I'll tell you, acceleration is difference of the masses. Obviously, you cannot subtract m1 from m2. m1 minus m2. m1 is bigger. Okay, difference of masses divided by sum of masses, m1 plus m2. Right, this whole thing divided by g. In the time, in the tension also, you have something here, and then you multiply the whole thing by g. Same here. Remember that. So it's very simple. Acceleration is difference of mass divided by sum of mass into g. So Ishma, what will be acceleration? What is the difference of mass? 4. What is the sum of the mass? 16 into, let's say g is 10. So this is equal to 4. 4 is 16. So this by 4 is 2.4 to the 8. 2, 4. Yes, come on. So 2.5 meter per second square. See that, students? It's already we have proven that acceleration of the system would always be less than acceleration due to gravity. That is the case. Then second, T. What will be tension? So I'll tell you the formula for tension. 2 times m1 m2 divided by m1 plus m2 times g. So Ishma, tell me what will be tension? 2 into, yes, speak. The more you speak, the longer you remember. Yes, sir, Jinder, please put the values. What is
6
m1?
into 10 upon 16
10
into
into 6 divided by 16 into, let's say this is 10. So this would be approximately 73.5 Newton. All right, students. So very, very important thing. All right. So having done this, students, let's also do what is impulse. All right. So students, this thing is somehow related to, a boxer punching his kit in a very fast manner. So there's a lot of force, and if he wants to still apply more effect of his punch, let's say this is his punch, he punches this. So if he takes the least time for the impact, the punch force delivered to the kit would be maximum. This is the application of second law of motion. Second law of motion. How? You see, students, applied force we have learned is equal to what? Rate of change of momentum. So change in momentum is m into v2 minus v1. Let's say v1 is final velocity and v1 is initial velocity divided by t. Now this t is very important. T can be understood to be impact time. Students, if t is more during an impact, when there is something which is striking something, right? So the time for which it strikes the second thing is t, right? And when it strikes, the force is delivered, right? There are certain things in this universe like magnet and electromagnetic forces, where touch is not important, force is delivered, force is applied even from a distance also, but we're talking about other kind of force where we need touch and the force is delivered. So if this t is more, f will be less. If t is less, f is more. So a good boxer or a karate person who wants to break a lot of bricks, by hitting this. So what he'll do, he has some force. Maybe he has same force like we have. We're not able to, break this, but he will break. Maybe we have more force than him, but he's very furtilla, very spontaneous. He immediately delivers all the force. Then he lifts his hand backwards to minimize the time of impact of his hand with these bricks, thereby delivering maximum force, and it breaks. Then we have crack theory, it breaks like this. Okay, fine. So this is related to this impulse. So what is impulse, students? So it's given by prod. Impulse basically is a measure of total effect of force. It's not force. Force is measured by second law of motion. It's measure of total effect of force. Students, it is it's something really interesting. You know, effect of force. All right, the force is there, but then its effect has also to be understood. Normally, a person will say, you see, when force is there, force effect is force only. It's something like there's some people, including me, we believe that the third law is not properly stated by Newton. It says that your action and reaction are equal and opposite, not always. There is a researcher I've heard recently who has told Newton did not take into account the shape of the bodies. I perfectly agree with him, but then I have an engineering, answer to, I don't know how that researcher said that. He might have observed something or what, but then I have really 5, 6, 7 years back teaching in lovely university, I could actually do it, or actually teach to the students. Let's say you are applying this force to, you're having this jet, and you apply this jet to this wall. The jet will get splashed, and somehow it will go back. So there'll be some force delivered to this, but you see, if you incline this plane and apply the jet, the force delivered by the jet will be less as compared to this case. And in case, students, something so very important, something very exciting, that if the shape of the body is like this, and if you put the jet here, half of the jet will go this direction, half of the jet will go in this direction. If you apply second law of motion, interestingly, students, whatever is the force with which this jet, the force, whatever this jet has, and the reaction given by this is actually double. This can be theoretically proven also. In case it comes straight like this is a condition that angle between this and this should not be, if it is like this, which is normally the angle of planes, then no, not double. But if the jet comes and it straight away returns here, it can be easily proven, students, the reaction is double. How could, if we believe Newton's third law that action is giving result to reaction, it can be considered action as input and reaction as output. Output can never be more than input. Never. Never in the engineering, never in the life. Output can never be more than input. But then in this case, it's happening. So that means reaction is not because of action. Reaction is NCERT book of +2 tries to touch this topic little bit. It says it should not be understood that reaction is because of action. Reaction and action, these are two independent forces. They take birth at the same time during the impact. Something very interesting, something a research topic. And then I'm very sure this law will be proven wrong one day. There are other dimensions to these laws which have not been stated. Just by saying that action is equal to reaction will not serve the purpose. Similarly here, students, force we have understood by second law of motion. Now we are going to understand the effect of the force. So let's see how. Effect of force. So impulse. What is impulse? We're going to finish it in 10 minutes. Very interesting in engineering. Impulse is equal to your average force during the impact. into time. Simple as that. This is a measurement of impulse. Okay. Uh, right. Average force into time. So now, according to the second law of motion, we know that F is equal to rate of change of momentum, right? In vector form, can I write like this? So we can write F dt is equal to dp vector. Am I right? If I integrate this on both sides, 0 to t, initial momentum here, p1, final momentum, p2. What I get? Uh, you know, p1 is initial linear momentum at t is equal to 0. And yes, Ishma, what is p2?
Final momentum.
Final linear momentum at some time t, right? And F average. Why I'm talking about average force? Because sometimes, the force is varying, so let's take some average kind of force, which is some total of resultant of this variations in the forces. F average is constant. Force may not be constant. We can take F average is constant. It's like somebody who's traveling with the velocity, you know, this much distance with u and then this much distance with v in a straight line. We can say average velocity is u plus v by 2. Doesn't matter. Distance will be same. So F average is constant during the time. So we may rewrite what? We may rewrite F average. What? See, integration of dt is t, right? T in limit 0 to t. Very simple. You know this, na? Integral dx is equal to x. Obviously, some constant of integration also. Similarly, integral dt is equal to t. Integral x raised to power n dx is equal to x raised to power n plus 1 divided by n plus 1 plus some constant of integration t. Right? But when limit is there, constant of integration cancels out, is equal to p vector, then limit p1 to p2, right? Or I can say what? F average into t. This t0 cancels out, is equal to p2 minus p1. Very, very important thing. What? Average force acting in the impact. In the impact for time t, there's variation of the force. So we take some average force. That's why this average is coming. Average force into t is p2 minus p1. So this F average into t I've already defined as impulse. So this is impulse I, which is also a vector, is equal to F average into t would be equal to the change in what? Yes, Ishma, what is this impulse equal to? Impulse is equal to change in anyone? What is P2 minus
Force.
P1? Not change in force, beta. Change in force. No, not change in force. Del P. Change in
Linear momentum.
change in linear momentum. It's like, you say that F is equal to MA, F is equal to M into delta V by T. Delta M into delta V is delta P by T. In simple form, you can understand F into T is equal to delta P. What is delta P? Change in momentum. All right. So, hence, impulse of force, which is a product of average force during impact and time for which I told you the impact lasts. Last means the impact happens, is measured as total change in linear momentum produced during the impact. All right. So impact of the force can be positive, it can be 0, it can be negative also. All right. As the momentum of the body increases, decreases, or remain unchanged under the effect of the force. So vector quantity dimensional formula for impact will be, yes, it will be force times T. So it will be forces M. What is force? M L T minus 2 into t is time. So that will be equal to mlt minus 1. This is the what? This is the dimensions of impulse. And what will be the unit of impulse? Yes, Ishma, what will be the unit of impulse? Unit would be force times
Newton second.
Newton.
Second.
Yeah, don't worry, don't get frightened. You know, don't get frightened to say something right, wrong, whatever it is. Say that unit is Newton second, or in CGS system it will be Dine second. All right, that's good. So 1 Newton second will be equal to how much Dine seconds? 1 Newton second would be equal to 10 raised to power 5 Dine second, because second is second. 1 Newton is equal to this thing. All right. So that's all, guys. That's all for today. So see you tomorrow. Uh, you know, with some numericals on impulse. Wish you all the best. Don't forget to like and maybe subscribe our channel. Learn CBSE on YouTube. Wish you all the best.